Alrighty, well, welcome again to another DFIR Python study group class, and we have a pretty interesting agenda for today. In regards to the book, chapter 7, we were dealing with SQL, MySQL databases or MySQL. Now I'm just gonna say SQL because that's how I was taught, independent of how correctly or wrongly it is. And what we did is we were logging our web app data to a file, and now we're going to be logging it to a database. And this is interesting and good because even if you don't ever plan to do a web application that writes to a database, this chapter introduces you to what are queries, how our database is put together. And even though we discussed some of that with SQLite, it gave way more detail on how that works. So that way, when you come across structures in your cases that, which you will obviously, that are dealing with databases, you know what the heck is going on, okay? This part, I thought it was gonna take longer to cover, but I don't think it will because it's really close to how we dealt with SQLite databases before. And it makes sense, right? The chapter explains that you can use, Python has a way of communicating with SQL-based databases, and it uses a couple of APIs to do that, right? First is the Python API, which we have discussed already previously when we connected to SQLite databases. And then there's the MySQL API behind the scenes that interacts with the Python one to actually talk to the database. That means that pretty much we can use the same type of code for any type of SQL-based database, which, by the way, another way of describing that, a more generic way, is a relational database, okay? Those are relational databases. We will have to contrast that with non-relational databases like NoSQL. It's kind of like the total opposite, right? Like realm databases, which we will cover in class in the future. Some ideas. We won't be able to code to it in Python because there's no API for it yet, but I will discuss some techniques on how to deal with non-relational databases in our cases. All right, so going back to the topic, right? So we got the Python API, which is pretty much kind of like how we have to make the connections, how to deal with that. All these different ways of doing these things is defined by the language. And then the database API. Oh, by the way, I haven't said what API stands for. API stands for Application Programming Interface. And what that is, imagine you go to a restaurant, right? And you're at a restaurant and you want to eat. They give you the menu, okay? That means that if you're at a burger joint and the menu has only burgers, you can only order burgers, right? If you go to the burger joint and ask for a pizza, they'll tell you that's not on the menu. We don't have pizzas, right? I mean, they might have the ingredients to make pizzas behind, in the kitchen, but they're not gonna make you one, right? Because it's not part of the menu. The API is the menu. It tells you this is the things you can order, things you can do at this restaurant joint, right? So if our database is that kitchen, then our API is that menu, and then we can ask the database, the kitchen, to provide us with delicious plates. In this case, delicious data to parse and digest. Okay. Hopefully that example made sense. If it made sense, give me a 1.
Clearly, it's lunchtime.
Yeah. Oh my goodness, you are absolutely correct. Absolutely correct. I see some ones. Okay. All right. So that's kind of like in a broad description what an API is. Okay. So let's talk about how we do this. I'm gonna go pretty much quickly because this is you've done this before, right? I'm gonna refer you back to when we worked with the Kick SQLite database. You notice that we imported the data that we needed to make that connection with the SQLite database here at the import SQLite 3 library. And we established, based on that library, a connection using the dot notation. In this case, we only send one argument, which is the database location, okay? And we put that in this variable, db, so it could handle that connection. And then we establish a cursor to be able to do our executions, or just tell the database we need this information. After that, within that same cursor or file handler, we said, okay, give me the results. And then we checked that we had results. And if we had results, Then we iterated through our list of results, and we pulled out what we needed. As you notice, as I'm explaining the code, I'm highlighting the parts that are responsive to that explanation, okay? At this point, hopefully, you should be able to kind of hear my words and understand what's happening behind those words. Like when I say we're iterating, you know what that means. I don't have to explain this part. When I tell you, hey, look, here we're checking if our list has stuff in it, right? Then you know that we're checking that if we have actual items in a list, okay? And again, this might sound repetitive, but I want you to get used to the language, how we refer to things. All right. Doing MySQL is the same thing as what we did before with SQLite. We just add additional things. What things are we adding in addition? Like I mentioned last class, SQLite databases are designed to be single user. So and I say user, it could be one person, but also one process at a time, right? You don't want to be having multiple things happening at the same time. And that's why here you have no need to provide what we do have to provide here in a SQLite database, which is a pretty much login information. Your database, your SQLite MySQL database is going to be sitting at a computer as a service, waiting for somebody to, ask for items from the menu. And you got to provide, you got to tell your script, where is this MySQL server at? In this case, it's at this IP. This IP corresponds, as you might know, to your local system, okay? If it were remote, then you would put the proper IP here. We're gonna provide the user, we're gonna provide the password. I changed it something super secure. and what database, because you could have multiple databases in one MySQL installation. Notice, and I have to make a quick pause. Notice that I have not discussed how to install it. The book goes into great detail on how to install it. And I said last class, if you come any hiccups on installing MySQL on your system, put it on the Discord or in the chat or both, or send me an email, and then I'll try to address those. One little, quick example, one little thing that I had the issue with is that the book doesn't tell me that, at least for the Mac OS installation, I have to go, and after I'm done doing my installation, I got to go MySQL .server start. What that does is it starts the service, right? If I don't do that, the computer's like, what are you talking about? There's no MySQL anything around here, right? It's a quick example of something that the book doesn't tell me, because most likely when they wrote it, the service started automatically, or maybe they were doing it on a Windows machine, which the service starts automatically. No, I had to start the service, like, just literally type it to make it go, right? So just one example. You come across stuff like that, like, look, I just did exactly what the book did, and nothing happened, or gave me an error, then let us know in the Discord, and we'll try to help you out. Now, assuming you installed everything is good, you're able to create the tables, and then you're able to go through this process. So we have to provide our SQLite database with these variables, these items, so we can log into it, okay? Talking about logging into it, let's do that right now, because I want to show you a couple of things. All right, so what I'm going to do is let's log into this thing. So I'm going to sudo into it so I don't have any issues with that. MySQL, right, minus user, it was vsearch, and with password, and I want to connect to the vsearch log DB. Let me make sure I wrote it right. It's going to ask me for my admin password, and then it's going to ask me for the password for the user. There we go. So we're in. Let me make this a little bit larger. Hopefully that you're able to see that. So now I have the prompt, and I'm at the within the database, specifically within the vsearch log database itself, not other databases, that particular one. And I want to see what tables do I have in this database. So I'm going to put show tables, okay? And I have only one table called log, which is the one we created based on what the book showed us, okay? I want to see what that database is about. What are the fields look like? What data types does it accept? So I'm just going to write describe log. And we see it right here. It looks a little bit funky. Let's open this up. Okay. So you see here, per the instructions of the book, we have different fields, right? And you can see them, visualize them as columns. The types, well, the types, int, timestamp, characters, multiple characters. If there's null, if it's a primary key, and at a scope, but we can discuss that a little bit down the road, that primary key will auto increment as new items come into it. It's going to be a current timestamp, et cetera, et cetera, et cetera. In this case, it's null, so they don't need that default. Okay, good. So our table is as we would expect it to be. Okay, so we're ready to actually put data into this table, because if you don't got a table, a database and a table to put data in, you can't. Okay, that's pretty obvious. Okay, how to set this up is described on the book. All right, so we got our script, and we got to provide the database with the login information, just like I did manually here. Notice that I had to go and type tam to get in. Your script is doing the same thing. Your script is actually going to this IP, and it's going to provide this information to the database, so the database can actually go in. Here, this is the code from the book, and this is not good, but here they import the actual information it needs to connect to the MySQL API. Kind of like what we did here for SQLite. Well, here we do it for MySQL connector. And actually, this should always try to be up here. Okay. So, but we can discuss that later. Okay. And then this is something I want to show you that I find pretty neat. So we imported this. So we reference this this library that we need to make those connections, and then we tell it to connect. And then we have this two little asterisks there. What does that mean? What that means is that whatever is in this variable here is telling the library that, look, what's coming, it's I would describe that as a kind of like an object, a compound object, if I might say so. And by compound, it means that, look, it's one variable, but there's multiple things in it, like a list or dictionary with stuff in it. And what these two asterisks do is they expand each of these key values and provides them as arguments to the connection that's being established behind the scenes. Okay, that's all it means. It means, look, what's coming, you need to expand that, and provide them as arguments, 1, 2, 3, 4. You don't have to do this way. You can provide the arguments 1 through 3, 4 like that, but this is way more easier, more convenient. It didn't make a lot of sense. It's fine. For now, just trust me, just do it this way. And it's gonna work, okay? We do the file handling, database handling for the database. And then we have the query. Again, nothing new here. It's kind of like you see this, how we did it here, execute and our query. What we're doing here is we are just putting the query inside a variable to then execute it. It's the same thing. It's just different ways of doing the thing, okay? And be mindful of that. There's no right way of doing a thing. If your code produces the result you expect with 100 lines, it's good. If it makes that same effect with 10 lines, it's also good. We can debate if it's more efficient or more clear to read, and we can debate philosophically which coding thing is better, but if it provides the result, it's good. Remember, these are words, and at some point there's art to it and personal preference. So don't be hard on yourself, and don't let anybody judge you. I digress. So we take our query and we put it inside a variable, as opposed to just feeding it into the execution command, right? But here we just put it in this variable. Why? The book explains pretty clearly what these little S's are. These are placeholders. It says, okay, for these tables in my database, which you can see here, phrase, letters, IP, browser, string, results, right? Phrase, letters, IP, browser, string, results. For these columns in your database, you're gonna put these values, and these are placeholders. These values will be provided in a second, and that second is gonna be these things here, okay? The phrase is gonna go into the first S, which is matched to phrase. The second one, the second value here is the letters, and it goes to letters. Remote address goes to IP, as we named it, and it makes sense, right? The agent for the browser goes to browser string, and then rest for results goes here. Hopefully that makes sense. So we provide to the execution command the query, and then what values are gonna be substituting the placeholders, the S's up here. I had an error because I typed everything by hand, and my error was that I did this. What happens here? It's 4 placeholders, but there's 5 things to be placed, and it gave me an error. It said that some arguments are not being used. And I said, well, what's going on? And then I had to look, and I figured out, oh, I'm missing something. So again, type things, commit errors. That helps you. And when you see that error again, you can fix it quickly because you've seen it before. Okay, so far, I know I said a lot of things. Is that making sense so far? Give me the usual ones if it do. If it doesn't, give me zeros. Okay. And again, you have to go to the book. And the good thing is that we don't have class next Tuesday. So you'll have plenty of time. If you want to really delve into this in detail, take the weekend and do some of this. Just run it. So it executes and then it commits. What does this commit mean? Commit means that the database does not keep the data in a cache, for lack of a better, or temp structure. It's not that it's being missed, it's there. But if you don't commit it yourself at the moment, if you go and try to select the data and look at it quickly after you do your insertion into the database, you won't see it. And you're like, well, what happened? It didn't work. It did work. It just hasn't been placed on the database proper yet. So you can do a commit to make sure it goes in at the moment you want it to. And you might ask yourself, oh, why don't we just commit all the time? Well, this is a pretty expensive process in regards to processing. So let's say you're in a big database. If you commit every single transaction, it's gonna go super slow. You might want to get, let's say if it's inserts, do maybe 100 inserts to that cache functionality, and then commit them all in one swoop. And that might improve performance, for example. Just an example. For SQLite databases, and I don't know if I talked about this before, you got WAL files. And WAL files keep all those transactions, and until something happens, it reaches a threshold, everything sits on the WAL file, and then it's dumped into the database, committed, I should say, into the database. So if you're doing SQLite, and if I haven't said it, then I'm saying it now, don't forget your WAL files. Don't pull the database and leave the WAL file behind. You need to analyze that separately, because there could be a ton of transactions in there that haven't committed yet. But in this case, if we're doing something simple, we don't care. We want to commit because we want to see that data quickly.
Sorry to interrupt you.
Yeah, go ahead.
Could you just talk a little bit more about that with WAL files?
Yeah.
Like a real world example, just because that sounds really important to me.
Absolutely. Thanks. I'm trying to see if I have one with a WAL file that I could pull quickly. Let me see if I have the original Kik databases. I think the Kik one did have WAL files, but I think there's a WAL file here. All right. Oh, there's a WAL file here. Okay, so perfect. You see this WAL? Can you see that on the screen, right? The little WAL file here.
Mm-hmm.
Okay, so I'll pause on the MySQL stuff because this is actually important. So when you have SQLite databases, they could use WAL files or they could use journal files. Okay, journal files. What they do is, and it would be like literally like the name of the database - journal. What that does is it keeps track of the last transaction. In case something bad happens, then it can revert back to the previous safe or good state of that database if something goes squirrely. Okay, that's what the journal file. So they're important. You might see like, the last transaction that one transaction that's not currently in the database because it got updated or changed in some way. So at least you get that one. Fine, we're good. You need to analyze that separately. And there's techniques for that I'll discuss in a second. Now, WAV files are more interesting. Why? Because they stand for write ahead logs. And what that means is that before stuff gets saved in here in the database, they kind of hang around in here. And notice how this WAV file is 190 KB, which is larger than the actual database. Does that make sense? You notice that?
Yeah, I think, I'm just sort of curious, about when you said something about it committing with Python. There was a point. I'm not explaining my question very well. Just continue. Ignore me. Continue.
Oh, no. I will get there. So
Sorry,
as things, no, dude, your comments really help me focus and narrow things down better. So let's say things are happening. We're reading and we're writing, deleting stuff, and all is happening here in the WAL file. It's not yet reached the cache. At some point, either, for example, because based on time, it's been 15 minutes, or maybe the size, I don't know, or maybe the amount of transactions. The developer decides when whatever's inside this WAV file will now be placed inside the cache. I say cache, but the actual database, I'm sorry, it's called cache here, but the database up here. And then it commits and it's placed all in it. And usually when that commit happens, if there's nothing else in the WAV file, the WAV file disappears. So committing is pretty much making sure that everything that's in these kind of either temporary in the case of MySQL, or in this case, like WAV files in the case of SQLite databases, when you commit means that everything now is sitting in the database proper. Does that make sense, Brooke?
Yes, that makes sense.
So at SQLite Browser, and since I want to make a copy of this because maybe the question comes in the future in a different way, and we might need to have a WAV file available. So I don't want to mess with it. So we're gonna use this copy here. Okay. So interesting. The SQLite Browser, when you open your thing with SQLite Browser, what SQLite Browser does is, you notice that how it's gonna start. Well, it's not. Don't look at this number. The number is fake. That's the uploading to the cloud. Because I'm on the desktop. Ignore that. What it does is it shows you the things. It actually, you can look at whatever data is here. Let me see if there's any data that's interesting here. Yeah, there you see, look at the data. Oh, look, the channels, all the good stuff, and the timestamps. That's pretty nice. I'm gonna close the database, and what happens is the WAV file went away, and now it's 131 KBs. You notice that? It committed. When I use SQLite Browser to deal with stuff and look at it, it will commit those transactions if there's need to be committed. If it's a transaction that means deletion, it will delete it. Okay, and then the WAV file disappears. Are you with me on that part, Brooke?
Yes.
So that's an example of kind of like in SQLite, at least, like a commit, right? We opened it and the software said, okay, I need to bring all this in. I say that because the WAV files might contain deletion entries. Does that make sense? If you open your database and your application, because SQLite Browser is not a forensic application, it will commit what it needs to commit. And if there is data that was deleted from the database, that record of deletion that used to live on the WAV file, you're gonna lose it. Are you with me?
Yes, no, I am. I'm thinking, I'm trying to phrase a question and not have it sound dumb. But I'm just wondering then, so if I'm, say, like copying and pasting the database file to analyze, right? Exported it from an extraction, and I'm copying and pasting to analyze somewhere else. If I were to open the WAV file, could that, I guess I'm trying to figure out, well, I guess the data would be edited.
Well, then I think I know where you're going.
Use Sanderson's tool
yeah.
instead. That is a good tool.
Oh yeah, absolutely, absolutely. There's and this I have to do it two ways, right? Because I have the Sanderson tool. I mean, that's what I use for sure, but I need to have an understanding on how to teach. For example, in my case, other partners in jurisdictions that don't have the money for any tools, right? How to do it by hand, right? So what my coding does, alib and ilib, it runs strings on the WAV files, so at least you can see if there's something that you can read that tells you that's important. You can read it, because the WAV file, you cannot open a WAV file on its own, like if it were a database. You can't, because it's not a database, right? It holds data for database use, but it's not a database like the same format, right? That's why Sanderson's tool is important, because does that for you. And any good forensic tool, you'll be able to handle WAV files appropriately. So what I teach folks to do by hand is, okay, before you open it with SQLite Browser to see what's in it, make a copy of the WAV files, right? Keep like Jerry's saying, keep a clean copy, and then you can look at that WAV file separately, right? As part of your analysis. And then if you want to kind of triage it, then just open the thing like I did, just open it with SQLite Browser and see what's in it, right? Let me give you an example of a case. There was this dude that has some contraband on his computer, on his phone, and he deleted it. So there were remnants. We can find the remnants, but the investigators wanted to know, where did this contraband came from, right? Was it downloaded through a browser or peer-to-peer? They couldn't figure it out. It was there. They need to figure out how did it got there, right? So I know, based on my research, there is this database, SQLite database in Android phones, Samsung Android phones, called My Files. And what the database does, it keeps track of all media that's on the device, and it tells you where it came from. So if it came from a internet web a website, it has the actual URL in it. Okay, so if you open the database, you will not see any of that information because that information was deleted. But this database had a WAL file, and all the deletion transactions, right, they were sitting in the WAL file. They haven't been committed. So they don't show in the database, right? They're still sitting on the WAL file. So I took the WAL file, and when I and analyzed it, I saw it was magic. You see the actual file names of the contraband images and the location from where they were being downloaded. So I can match, look, this particular picture named X, Y, and Z was actually downloaded at this date from this location on the internet. And then the investigators could then follow up those leads to wherever it may lead. Okay, so that's why you need to analyze WAL files separately. Can you do that with every single WAL file on a device? Oh my goodness, no. Because I mean, you have to triage it. You have to figure out, is this a database that I care about? And if I care about it, there's a WAL file or a journal file in it, and then act appropriately. My scripting, what it does is quickly run strings on all WAL files. Strings means things that we can actually read, that make sense, that are not computer language, it's human language. And I can quickly go and check, okay, and look, if it's like, if I see in a WAL file chats, then note, I need to analyze this separately. If the WAL file has URLs, okay, note, I need to check this separately, and then go from there. Yeah?
Very helpful. Thank you.
Yeah, so I want to show you that. So
Thank
in
you.
a, say what?
Thanks to people who commented too.
Oh, okay, awesome. No, yeah, look, yeah, a clean, yeah, exactly. Like Jerry's saying, keep a clean, and then examine that separately, absolutely. So I gave that that example because we've done SQLite before, and it's pretty much the same with MySQL, pretty close to it. So we're committing, making sure the data gets in there, and again, obviously there's no MySQL WAL file like that. It's not a WAL file. WAL files are for SQLite, but the concept is the same. And then when you're done, you want to close your cursor, your database handler, and you want to close the connection. We don't need it anymore. Let's tidy up and close it. Okay. So let's see how that works in practice. We run our service or script, which will enable the web server. I have my Twitter up, but it's not what I want to see, nor my calendar. I want to see Safari. There we go. All right, so let's go here.
The calendar looks pretty empty, Briggs.
For today, thankfully, right?
Really, don't have enough to do.
For today, thankfully, at least during the day. All right, I'm gonna put my name because I'm all full of myself. All right, so and I'm gonna. So hey, look, this is successful. This is fantastic. Everything seems to be fine. Where's my logging? It's not on a file anymore. It's in the database. So let's go get it. We're already in the database. So in order to get stuff out of the database, we're gonna use one of the queries we used before. We're gonna select, if I could type, select everything from log and see what we get. And let's open this up a little bit more. Look how fantastic it looks now, right? So we got ID 3, and the reason this is ID 3 is because I had already put some data in it and I deleted that data. So it's a sequential ID, and I know that because it's auto incrementing. Actually, let's just test it, so you don't have to believe me. Let's do this again. I'm gonna put Brooke because Brooke is awesome. All right, there we go, and let's run this little query again. See, now it's 4, and this is a good point. You might find databases on your research. And that, again, don't assume, you have to research, where you're like, okay, I got ID number 3, 4, 5, I'm missing 6, 7, 8, and then I got 10, 11, 12. What happened, right? If your research shows that your database is incrementing items sequentially, that is an immediate giveaway of deletion, or something squirrely is happening, okay? So that might not always be the case. It could be an instead of an auto increment, it could be randomly. It could just generate a random number to act as an ID for the field, and you cannot make that assumption, right? Just keep that in mind. Make your research, and if increments sequentially, that might be an indication of deletion, indication of intent, and it might lead to further investigation on your cases. Okay. All right. So in order to delete this, since I talk about the deletion, let's, what you do is you delete all from log, just to kind of show you how you, oh, what did I do wrong? Oh, hold on. I thought I did this right. Is it delete? I think it's delete plain. There we go. It's without the all, just delete plain, delete from log, and it clears it out. So as you can see, there's nothing in it. I did a select, it's empty. But if I go back again and, you know, do an action that generates login information, now it's being properly sent to the login. As you can see here, we had 3, 4. I deleted it, but now we start at 5. So where's 1 through 4? You know, food for thought. Okay. All right. The rest of the chapter, and we will discuss briefly next class when we get together again. It's showing you a better way of optimizing this code that we're using here. So do check that out. It doesn't really add anything super new to it. And then the next chapter is going to be a little bit of a challenge for everybody, me included. We're going to learn a little bit about classes and object-oriented stuff, which I'm really happy we're doing this together because I need it as well. It's something that I'm really looking forward to learning together. So please take the time to read. It's a long chapter, but well, not really that long, but has a lot of data or stuff in it. Take the weekend and please do read chapter 8. If you can do everything in chapter 8, do it as well. So we can work together on this, okay? Now, we're supposed to be done. Do you all want to continue talk about put above now, or should we leave it for next class? I'm willing to stay here till 1, but I don't know if people want to eat now or what. If you want me to go on, give me a 1. If not, give me a 0. And if there's more zeros, then we can discuss this later. So talk about put above now, 1.
Someone says they need to leave in 10. Either way, I need to go. Let's say that I think this seems like a good stopping point.
Okay, perfect.
That's my feeling.
Oh no, that's good. That's why I'm asking, so I can get a good feel for what the class wants. Oh, that's perfect. Then good, cool. We'll do objects. I mean, we'll discuss quickly the end of the SQL thing. It's just like 3 or 4 pages. Next class on Thursday, right?
Thursday, yes. No class Tuesday, Thursday.
Yep. And then talk about as much as we can about in 15 minutes about classes and object oriented, and then talk about protobuf, because protobuf, I think everybody's gonna enjoy it quite a lot.
Yeah.
All righty.
Cool.
Thank you, everybody. And I'm gonna stop the recording at some point. Where is the thing? There we go. I'm gonna stop the recording now.